Hello. Good evening. Thank you for tuning in. Or thank you for watching on YouTube. I don't mind. Guess I'm supposed to say like, comment, and subscribe or something. Hold on. Let's pull requests. This is where I feel bad. So, 3 pull requests from Scott. A kinda helpful helper. Oh. The FPS. If it doesn't equal 0. Wonder why it would be 0. This is the thing that draws that circle. I'm gonna say we don't need that. Sorry. Refactored some math helpers out. Added tests. Okay. Tests is good. What maths helpers do we have? Rounded, degree. Okay. Points to angle, angle points. Between angles. Limit 1 less than limit 2. Angle greater than limit 1. Angle greater than limit... Wait, what? Huh? Less than... Oh, so... Oh, okay. Whether the orders... Yep. I guess that makes sense. If limit 2 is less than limit 1... Oh. Then what? Okay. I think this is cool. That help us. Test is good. Yeah, take it just for the test. Yeah, I don't know if I like the name math helpers, but I was thinking, actually, refactoring some of those out today. So there we go. Head start. Alright, what's next? Full corner refactor. I think I'm... Yeah. I think... So, this is probably what I wanted to do today. Yeah. But... No, so... yeah. This is what I really... Like, this is what I was gonna... This is what I'm planning on doing today. So, let me put that out there. I could merge this and do something else today, but... So my big problem with all this math code, which I never want to see again, but I just couldn't pick it up the second time through. And I think if I cheat and take this refactoring, that's going to make that problem worse. I think by refactoring it, like, I want to refactor it line by line kind of thing, not here's a whole chunk, but... Alright, cool. So yeah, the job today, get rid of that, is to refactor this stuff. Let's pull down those changes. To refactor these 4 methods into hopefully one, or just into something that makes sense. But there is also more directions to go here. There is left, right, down. Left, up, down. Let me just lay them all out. Or do I refactor first? Let's refactor first. Now, the first thing I'm going to do, I think, so these are all static methods. Move counterclockwise, move clockwise. I could put move vertical. I think I'm going to... where's math helpers? There it is. I think I'm going to say this is... I'm just going to call it train movement. Because I think... Oh! It renamed the file for me. Did I just press yes to a dialogue and not notice, or is that new? Interesting. Anyway, I think I'm going to put all of these methods in here as well. And I could move that in as well, because it just needs to take in a direction. And then it would make things more testable, I guess. Yeah, maybe not. I'll leave it. Alright. Let's just move all of this out. No. Let's leave move cross. This is a little bit of hedging. So, right now tracks are all represented by this track class, and they have this track direction that moves them around. In future, I would like that to be different. I would like there to be different classes for tracks, different track types and whatever. This one might stay a simple track, but maybe not. But I could see something like a cross being separate. So the logic of when how to behave on a cross, I think, belongs here, but this move stuff doesn't. So this can still hand off to those two methods, just that those two methods need a different class, that's all. I think that makes more sense. And wait, between angles, was that you? I don't think he's used that. It would be here, yeah. I might have to try that. Oh, so radius. I'm actually totally fine with hard coding that to 0.5. And what was this? Outside cell angle padding. Let's hard code that as well for now. We can always extract them again. So we just get a bunch of cursors. Oh, and two more. And we type in train movement. That should all compile now. No? No, because they're still private. So is there a key combo for select all? Is it Alt Shift semicolon? Yes. Hello. Awesome. Alright. The doubles and the floats are a little bit annoying too, but that's life. Like they're mostly floats, but some things are angles. And yeah. Anyway. Cool. So this should all compile now at least. Nope. Fine. Oh, interesting. Double to float. Oh, so there's only F's. Okay, that's interesting. That better? That's better. Alright. So what we have is a bunch of methods. I'm going to make that a full one. Okay. So what we have is a bunch of methods. move left down, move back down. So they all get the current angle. They all take. Oh, and then we've got this tuple here, which I kind of want to convert to a class. Convert to struct. Ooh, convert to struct in containing project. Oh, nice. Train position. Let's go with train position. Oh, I did all of them. Look at that. That's awesome. Oh, and it even... Where are we? Where to go? Where's train position? I said in this project, didn't I? Is it down here? Ah, it's down here. Can I like extract this to a file? Oh, move to type. Look at that. Thank you, Rosalind. You are awesome. Helping me every step of the way. I'm not in love with public floats. I think I'd rather have getters and probably... Actually, do we need setters? We don't. Oh, that's because this code is all doing this, which is really got a... Yeah, we've got an operator there. Interesting. Interesting. So it's converted that to a struct, but it hasn't had to change this code because it's implemented a converter from the tuple. Which is cool. I do wonder though whether we maybe just take in a train position and return the same one, essentially. And just set the properties. Like here, instead of setting these fields here and then... Like what are they saying? Can be removed. It's not part of a shippable... Its initial value is never used. Yeah, see, like stuff like that. Yeah, this could take in a train position. I think that might be a good idea. In fact, I might make it a class though, because I don't want to copy around all the time. Let's make it a mutable class. And I'm not going to bother about this because I know I'm not going to use a dictionary for it. I will leave this here, but I don't suspect I really need these. Oh yes, I've got to make this. No, let's make this internal. That should have got moving warnings. Yes. Okay, so alright, anyway, back to here. So move left down. So what we want to do is we want to make a new... if it's a class, it doesn't have to return anything. Move around corner. And we simply take in a position. Now, what type of corner? So, first things first, we find out the current angle. Move left down, that does this. So this, can I extract this to a parameter? Generate variable. No. What I want this to be is this is the Y offset. Is this the Y? This is. So this, what this is saying where is our position relative to the middle of the circle. So let's go with Y offset. So we want a int X offset, int Y offset. Good evening, Scott. Did you miss anything other than me rejecting a bunch of your pull requests? No. I took one of them. So no, I'm just starting to refactor all of this movement code into something somewhere more sensible. Okay, so it's never used. Yes, it's come on, catch up. So is X offset. I have two X offsets. How did I do that? Okay, so we have our X offset. So the next thing we do is our angle to move, which is our distance by 1/2. So this is position.distance. Okay. I'm just going to copy all of this. So, angle. So I'm assuming this is where the between angles, train angle, that's position dot angle, and 130 and 315. So I'm guessing that's where they go in. So this is the, what is this? Let's just do this for a second. So if we want to move a train, let's say we have a train position. Remember that. We want to move around a corner. See, that name. This is not a fun API to call. X offset. So let's say I wonder, we could make it an enum. Anyway, let's so X offset, that means like what that is relative position of the center of the circle. And actually that should be plus. Because if I'm, oh no. Just trying to work out if you call this, how are you going to reason about what to pass in? So X offset makes no sense. What this is this is the what is this? This is the distance between the left hand of your cell and the center of your circle. Oh, I cannot express that. Yeah, 225 plus minus 90. That's where I was. That's what I was going to next, is having one parameter, but I'm just trying to work out what to call all these things. X offset is just the wrong label. So what this is let's just go quadrant position. Offset is just quadrants, yeah. Quadrant position X. Quadrant position Y. And you know what? We can do this. So position is the train's position. Okay. Quadrant position. Quadrant position can be derived from the 225. Yeah, I guess it can. Oh, that's interesting. That's a good thing to do. Maybe let's do that later, because if I refactor too much in one go, I'm going to potentially break stuff. So this is the distance between the center of the circle and the left-hand side of the cell, I guess. That sounds a bit funny, but never mind. The top of the cell, and I'm gonna just do that so we don't need to worry about units, because I know what I'm minus them. Okay, so then yeah, we have these two angles. So okay, so if we're going left up, it's 0, 0. Then we want to pass our angle, and so where the angle would be for that would be 45. So what's that? That's the midpoint. Midpoint angle. So midpoint angle is the angle at the middle of the arc you want to move. Does this only work in arbitrary arcs? Okay, and so then this is midpoint minus 45, 90, and midpoint plus 90. But I'm not sure about that. $135 and $315 is just 180 plus minus 90. What? It's what? That's not. It's 225 plus minus 90. Anyway, okay, and then well, then we have our minimum angles. So sorry. Anyways, what I was saying, the between angles thing. The only thing I'm not sure about there is, no, your math should be okay, because yeah, this will just go more than 360, which is fine. Yeah, okay, that's cool. So distance is position dot distance. Now this one is minus 90, but we need to, I'm going to get rid of the radians here. So 45 is our midpoint. This should be move left up. Actually, you know what? I just realised why you made this public. It's for tests. And actually, I can do this. So that's helpers test becomes train tests. Look at that, it just renamed, it didn't ask me anything. That's great. I think that's Andrew. Well done, Andrew. Andrew Hall. Thank Andrew Hall if you're seeing. Let's just quickly whip up a fact here. Query letter for 160 is moving of the quarter angle 45 and the train angle which we perpendicular. Yeah, maybe. So let's just make a train, and we're going to put it at. So let's put it at. What are we? Left is 0.01. Top is 0.5. Angle is 0. And distance, I don't know. Let's put in the 1. And then what I'm going to do is, so train movement dot move left up. Expected. So if I call move left up with left top angle distance, so that should get me the same thing as, so set.r equal, I just deleted the equals method. What is it? Set.equal, yeah. Expected.left and p.left. Okay. Top angle and play the program and see how it works. That's a good idea. I should do that. Unfortunately I've kind of broken it, but that's okay. I can put it back. I think we can just do this. Let's do this. Thank you, Gerard. I hope I pronounced that right. It doesn't compile. No, I think it will. I think it's just unless it's catching up. My computer is slow today. I don't know why. Okay. This is what it does. You draw some tracks, and then you put some trains on, and you watch the trains go around. And if it looks underwhelming, that's because the trains have only been going around for about 3 minutes. This was what we did. Well, what we managed to do last stream was get basically one corner worked, and on the last stream got the rest of the corners to work. So yeah, so I'm just refactoring this. Is today's job to get this the code nicer, and then doing things like collision detection for that, and for like if 2 trains are in this thing. And we also need to do T-intersections, because right now they crash the game. So yeah, that's what I'm doing. Essentially, what I'm trying to do, realistically, is refactor the code in order to prove that I actually understand it. Which I'm not convinced, but we will find out. Okay, so yeah, so in theory, if I run this test, does this compile? No, okay, let's get this compiling first. Can I put a bar there? That's weird, no. Okay. Current angle already exists, so we want a var there. Oh, I can't do that. The expression cannot mistake functions expression. Oh. What type are we? Float? Float. Okay. So this is position.angle. This is position angle. Distance is distance. Position angle. So yeah, once I've got this actually compiling, we can then, in theory, this doesn't turn anything. We can, in theory, run that test, and I would expect it to fail, but it should at least validate what's going on. And maybe with a bit of luck, we can even get live unit testing working, so we can just see as we go what's going to happen. So as long as this fails without throwing an exception, I'm happy. Yay! Cool. That's good. So that failed just because I'm comparing it to move left up, but I copied the code from move left down. So, okay, so yeah, let's see. Let me turn on live unit testing. Start. Look. Get a window here. And you can go. Alright, so we should start to see some little ticks now. Hopefully. Awesome discovery that the third program is actually going to double its floats. Oh, what does that do? Is that like precision? Ah, it's precision. Ooh. Oh, time span. I got very confused there and thought, how do you specify precision time span for a float? Okay, cool. So live unit testing is working. That's good. We only have counterclockwise tests. That's cool to know. Alright, so here we are. We're here at math.py. So this is... I'm going to pass in -90. And so this is going to be int minimum angle. So this is going to be this is degree to rad minimum. Oh, double. No, it doesn't. And this is degree to rad maximum. Now those angles though aren't train angles, just to be annoying. So we might have to fix that up later. So left, right is 90 and 0. That doesn't sound right, so it's probably 0 and 90, but let's just find out. It's going to run our tests now, right? Run the tests. No? How do you know it's... Is it done? Did it finish? Ah. Okay. Distance. Okay, and then here we need to add on our X back on again, and our quad position Y. Why do that one? Oh, whoops. Because you can't just write code like that. Plus equals that, and plus equals 2 pluses. Okay, that's Y. Alright, and run the test again. Maybe they'll pass? Not really confident, as you can probably tell. Okay. You running it? You doing it? Come on. By the way, is this crashed again? I think it's crashed again. I did 0, 0, yeah, okay. Let's just run it the old-fashioned way. Ah. That's why it's not running them. Now try. Okay, it still failed. How do I see the failure? Oh, look at that. It's a precision thing. Oh, no, it's not. No, that's completely different. Alright, now for the hard part, work out what I did wrong. Hey! Nice! Okay, so this is left up and around the corner. Let's go... No, I'll tell you what. We need to do clockwise first. So we've done counterclockwise. Now for clockwise, what do we need to be? We need to be at 90. And distance of 1 is fine. This needs to be 0.5. This needs to be 1. We're still in the same position. Our midpoint's still the same. Yeah, this is all the same. Okay. So that didn't work. Oh, it's still not covered. Wait a minute. Didn't that just pass? Am I blind? That went green, didn't it? When I changed this 0 to 90. Oh, no, this is wrong. Oh, hang on. Have I got maximum angle? No, that's right. Maximum angle, minimum angle. This is covered by one test. Alright, let me make it 2 tests. 2 tests was better. Counterclockwise. Okay. So that one fails. Okay, so that one passes. Okay, cool. So this one fails. Now, a purpose of random guesswork. No, okay. Right, why does this fail? So, okay, it's not these parameters. These parameters are all right, because these parameters are essentially hard-coded to be whatever this uses. So move left up 0 and 90. Let's have a look at move left up. What is the actual? It says here 0 and 90. Okay. 45 and 225. That is not at all what these. Oh, I see. This is. Sorry, Scott. Is this, you said line 67? Yeah, I think it's, well, it's now line 61, I think, but it was line 67. So that's the train angle, midpoint angle, not 45. No, that's right. Isn't that right? Also, why aren't these lines covered? Like, this is covered by 0 tests. So that's covered by 2. Okay, well, there's definitely a problem. So, we're coming down. That's 90. But it's not. 45. 45 minus 90. Yeah, that's. Okay, that's wrong. Hang on. Left up. Alright, so it is this line. This line should be sending our second test through this branch, and it's not. So what are we saying here? If between angles, midpoint minus 90, midpoint. Oh, right. Is this the wrong... Did I change this? Is that supposed to be... Yeah, no, train angle. Is it supposed to be current angle? Now. Evidently not. So, close. No. Okay. Let's think about this. So, A midpoint of our corner is 45. Yeah, that's completely wrong. A train on that track is going clockwise if its angle is 90 or below, and it's going counterclockwise if it's... No, sorry, it's 90 to 180. Right. Okay, so clearly I can deduce this from these, or vice versa. But what I need to specify here for the midpoint angle, that is not the midpoint of the curve, it is the angle between that lies in the middle of going clockwise and anti-clockwise. So for this curve, let me paint.net again. Should have left this open from last week or 2 days ago. So paint.net, there we go. So here's our circle, and draw some axes. So we're talking about left up, which is this part of the circle. So a train is coming in. If it comes in here, going in this direction, it's 0. That's going to go around to here, which is pointing up. So that's 270 / minus 90. So that's 0 to minus 90. If it comes down here, it's 90 degrees, and it goes to 180. So the midpoint is between 90 and 0, which is 45, which makes sense. Oh, I know what I've done wrong. It's midpoint angle minus... It's, hang on, let me write this down. So counterclockwise is 0 to minus 90. Clockwise is 90 to 180. So 45 is in the middle of that. But what we need to do is, if the train angle is it just less than and greater than? That seems too easy, because that doesn't match what we had before, but if the train angle is less than the midpoint angle, I think these tests will pass. I should stop making mine edits and let live unit testing catch up. And have I forgotten I always forget a semicolon. Oh, God, that was just me undoing one too many times. Hey, test pass. Alright. Cool. So I'm thinking, well, actually, what we need to do is we need to test a few more. So let's go left down. Let's test that. Okay, so left down. Oh dear. Left down counterclockwise. So that's this one. Oh, now I've got to remove all this writing. Okay. So left down is this quadrant. So left down. So clockwise. Oh, how we added complexity for the sake of verbosity. Yes, we did. I want to get it right, and then if we've got tests, I'm happy to simplify it. But I also want to be able to understand it later, and like performance for this part is not input. It's plenty fast enough. So we're coming in. We're going to go counterclockwise. So that's right. That's right. Our angle is 0. Our distance is 1. Okay, that's fine. We're going to move left down. Now we're going to go around the corner. Our position is fine. Our quadrant X is that. Quadrant Y, yeah, see, logically I want to pass in -1. Our midpoint angle is then 315, I guess. A minimum angle, so 315 being, yeah, that's right, 315 being here. Our midpoint, minimum angle, when going counterclockwise, gets down to 0? No, 90. Wait, it's coming in at 0. Oh, is it going down to minus? No, I'm confused. A maximum angle, then, fine. Every time I say maximum, my Alexa in the corner lights up. This is going, if we're coming in from here, we're going 270, and we're going down to 180. But that's, oh yeah, sorry, counterclockwise, that's right, 180, and then this is 360. Didn't work. Let's just check this. So -1, 315, 180, 360. So I think this one is a problem because, like, these angles don't. So this is 360, but it's also 0, and it depends on whether the math and the helper functions sort of allow for some of that. So yeah, so like this is negative. Yeah. So 360 is 0, but as a maximum, that kind of doesn't make sense, does it? No. And then, or is this the one where I had like -180? And one of them I had -180 as well. So, alright, let's debug this, shall we? And see what we get. Or we just leave it as separate methods and not worry about it. Because this, I mean, I'm kind of glad I got tests, but boy, this is fragile. I guess I should maybe make this test. Maybe just hard code these numbers as results once we've got it working. Okay, so that's cool. I just realized I could actually look at the code. Yeah, so that's minus. So there's our problem. Maybe the answer is to normalize that current angle, because that's gonna be what's that? That's essentially 270. Actually, we can just do here. So if we go rad to degree current angle minus 89, yeah, is going to be just under 270. Right, so essentially 0's here. We can go all the way around to 270, or just over 270, sorry. Go all the way around to here, or from 0 we can go down to minus 89, but it's the same angle. So normalizing this, see now if I go, does it keep between 0 and 360, add 2 degree, current angle, float, yeah, so 270.1. I could actually, I think I could just do degree to rad. Is this functional programming yet? Really? Let's try that, because I should be able to just set that, and that should actually pass the test. No? No, evidently not. What went wrong? Oh, it's still negative. Oh, I guess there's something else that needs it. Let me just try this though. So current angle equals degree to rad, keep between rad to degree, current angle. And obviously I could just write a keep between 0 and pi times 2 as well. This is fine. Again, performance, not what I'm worried about at the moment. Now, are these tests still pass? So that hasn't gotten any worse anyway. Alright, well, let's go back to debugging then. See what next is wrong. 315, 180, and 360. That sounds right. So 4.47. So just to add to degree, angle, just to make it a bit nice. So 270. That's cool. Oh, wait. Our train's at 0. Yeah, so we're going counterclockwise. Moving 2, that's fine. And then our minimum angle is 180. Minimum angle. So that's going to take us below our minimum, which means we're over. Well, that could be okay. These are big distances. Maybe these shouldn't be such big distances. Only over a tiny bit. Distance is 0.7. That sounds okay. Our angle is about pi, so about 180. That's fine. Our train angle is going to be close enough to 90, this makes no difference. Which is good. We came from 1, we've come down to 90. We've got some distance to travel. We're within 0. So now, angle to points is where it's getting wrong. So our relative left is minus... Oh, hang on. Did I pass in the wrong... No, I can't have. Left plus equals y plus equals 1.05. That's right, because it is supposed to go into the next cell. But so left has come out negative when our current angle is pi. Yeah, actually, I don't think our current angle should be pi. Let's try a much smaller distance and see what happens. All of the F's. Because there's a chance that... see, this one failed now. There's a chance that overflow code was wrong anyway, or that something I've done is wrong, because that pretty much is not going to happen in the real game. Like, you'd have to be going very, very fast, which we haven't got a speed control yet. So, yeah, okay, that doesn't really surprise me. Although I'm a bit annoyed this one didn't come good. That 180 and 360 feels wrong though. It's got to be 270, right? It's got to define that quadrant. Minus 90 and 0? I'm just gonna guess numbers now. Ah, dear. Okay. So let's see if we can work out why this one's gone. Where this one's gone. Tell you what, I'm really tempted to just not bother with this and leave the 4 methods because I don't want to get to the end of a stream and have nothing to show for it again. But we'll see. The current angle is 1.5 and that should stay the same. Good. That's fine. We're at 0, that's fine. So we're going counterclockwise. So our angle is lower. I guess that makes sense. I don't know. We've gone to 78 degrees. And what we came in? 0. So 0, we've gone to 78, so we're going down. That doesn't sound right at all because we're in this thing. We should be going up. Huh. That is a problem. Okay, so the minimum angle here is wrong. So the minimum angle here, I've said 0. What was it in left up? It was 0. That's... yeah, F for my sanity. Okay. I'm doing this. Put a breakpoint there. And put a breakpoint here. And let's just see what the difference is. Because these two, oops, not run, debug. These two methods should be doing the exact same thing. Okay. So 1.56. We're going to move 0.2. Distance is 0.1. So from 1.56, we end up at 1.36. That's exactly what we had last time. Ooh, train angles completely different. Oh, maybe not. Minus 11. Alright, so anyway, 1.56 to 1.36. So we have 1.56, 1.36, and minus 11. Distance is 0. We keep it within 360, so 348. What? Must be this. Or this. Or this. Or this. Or this. Well, hang on, maybe... ah, okay, no, that's okay. I should have checked that. That's a precision thing. Okay, let's... right. Where are we? Float? They'll probably get converted to decimal. So this is what? Number of decimal places? Let's go with 4. And hope for the best. I'll probably change angle to ints anyway. Because, no, that's all in degrees. Well, I guess not. Once we put in speed control, we might save it all. Okay, so now these should go green. No. Grr. Where are we? Move left, counterclockwise. 348.4263. Oh, they what? Seriously? Look at that. Okay, so is that just the loss of precision from this? Yeah, it is. God. Oh, that's annoying. Alright, so then now if I have to leave that as negative, fine, but now we're back to the problem of what the hell are these numbers? Minimum, maximum. Alright, so this is move left down counterclockwise. So move left down to go counterclockwise is between 135 and 315. Okay, so left down, if it's going counterclockwise, it's coming in at 0, ending at 90. And if it's going clockwise, sorry, that's clockwise, 0 to 90. Counterclockwise is 270 to 180. Oh, sorry, it's not that, it's this. Minus 90 to 0. Minus 90 to 0. Well, the 0 is thing on, but didn't I set this in? It failed. I tried this already, didn't I? Yeah, so that still fails. Minus 90 to 0. Move left down counterclockwise. Yeah, it's on the wrong... It's on the wrong side. Okay, well, debugging again. If the first number is bigger than the second, then it's OR, not AND. Yeah, I'm calling... Oh no, I just did this midpoint angle thing. This is based on that. Maybe that's wrong. I feel like the failure is coming from this line more than this line, but that could be wrong. Alright, let's just do the debug thing again. So, oh, no, it is that line, because look, this line's not covered by a test. Oh, wait. Wait, hang on. What? Why is that line not covered by a test when I have a hard-coded thing? Oh, unless I stuffed this up. Oh, I did, I stuffed this up. This isn't moving counterclockwise at all. This is 999. Okay, I think that's better. I mean, it still failed, obviously, but no, this still doesn't have cover. Okay, hang on, what have I done wrong? Left down. So counterclockwise means we're coming up at the bottom, so we're in the middle of the track horizontally, and we're at the very end of the cell vertically. And then our angle is not 0, that's for sure. Our angle is 270. Ah, okay. So it turns out if you get your test data right, amazing things happen. And so then this is minus 90 and 0 as well. Yeah, see those I'm never going to get that minus. Oh no, that doesn't work. I was going to say there's no way I'm getting those numbers right from, like, if I was calling this API. 0.5 is okay, so clockwise. So that's 0.01. That's 0.5. And what's the actual failure? No, still negative. Okay, so move left down clockwise. Maximum passing is 0, which is the same. So, I wonder if this, yeah. See this? This is covered by 1 test, and it should be covered by 2. So now this line is the problem. Okay. So what I've said there is the angle is less than 315. The angle is less than 315. That's clearly wrong. Yes, it doesn't make it much nicer for the camera. I mean, look, yeah, I could pass in an enum here for what quadrant to use, but then if I'm going to do that, I may as well just keep these methods. Maybe that's the answer. Or I guess I just keep those methods and they just call this one. Yeah, that's probably the best way, actually. And then, yeah, then I don't need to worry about this necessarily making sense from outside this class. But I still need to work out this. So, most of these, they have 2 angles here. Alright, let's just, so 135 and 315. Let's just do 2 angles. And then move left up is 45, 225. Let's see if this works. I've ceased to understand the code, which is of course the problem of wanting things to just work. Excuse me, I get lazy. I don't know even know what to call this. It's certainly not midpoint angle anymore. It's got to be max train angle counterclockwise and min train angle counterclockwise, maybe. And so then now we call between angles angle, angle and straight angle. Is that going to pass any tests? Go back to having failures that used to pass a bit. And oh, look at that. Well, this one's completely wrong, but 0.48 to 0.5. Okay. So, I mean, this isn't going to matter, is it? So this could be that the between angles method is wrong. Although, did you write tests for it? Yeah, you did. Within angle, outside angle. So there's tests for between angles. So I think this was move left up. So move left down is between, so it's inside 2. Move left up is outside. Yeah, so no, that should be, because I think that's how you did it, right? Outside. Oh, other way around. Oh no, that worked. Oh, okay, cool. Yeah, that's. There's no way anyone not calling this method would know that. Oh, I need the bigger one to be here because it's outside that or whatever. And I certainly don't know what to call the parameters to do that, and I suspect you don't either because you call them limit 1 and limit 2. Yeah, okay, cool. We can do this. So, move left down. Move left down. Oops, lost it. Sorry for all the scrolling. Okay, move left down is train position P left stop angle distance. We call that and we return P. That should work. And then move left up. I can do the same thing. I can do that. So move left up is, this is 0, 225, 45, 90, no, 0 and 90. And I've just broken all my tests because, of course, these now just call itself. But yeah, that's right, 0 and 90. Okay, cool. So let's just double check. Now that we're using the real new method for real, let's make sure the trains still work. Whoa! Oh yeah, that'll work. Unless there's no T intersections. Let's hurry it up a bit. Come on, test faster. So that all looks cool. Alright, I like it. A lot less duplicated code. Okay, on to move right and move right up and move right down. Okay, so, you know what, since these tests... Well, are these tests useless? Kind of tempted to maybe hard code some values here, but... Nah, they're pretty much useless. Oh, don't do that. So let's just do this. This is move right. Immutable structure. Who's got an immutable structure? It's a mutable class. What? Mutable, yes. It is a mutable. Well, that's because this just moves the train. Like, here's a position of train, go and move it. Done. Otherwise we end up copying structs everywhere. Okay. Oh, why didn't that work? Move right. Move right. Okay, these should all fail now. Excellent. And so all I need to do is copy the numbers. Yeah, now that I've decided that I don't care about calling this API, I just can copy the numbers. So move, that's -1. That's 45, 220. That's -180 and 360. Whoops, 360. And that, I wouldn't have thought that passed because that's weird. Maybe it didn't go. Oh, it probably didn't go counterclockwise. Okay, right down. Right down is, so counterclockwise is coming in this way. So angle is 180. Our left is 0.99. Yeah, this one went clockwise. 5 and the loop. Cool. And then we'll copy this again. I could have just swapped these methods. Yep. So right down clockwise means left is 0.5. This is 0.01. And that should be green. Yes. Okay. Oh, this is so much faster. So now, that's right down. Done. Just do that. Just that. And grab that one. Right. Yep. Okay. Right up. Lucky last. Right up is counterclockwise is so minus 1 on the left, 45 and 35, 90 and 180, 90 and 180. Awesome. No, not awesome, because right up counterclockwise. So counterclockwise means we're coming up from the bottom, so the angle is 270, left is 0.5, this is 0.99, and now it's going green. Yay! Good. Copy that, paste that, and clockwise for right up. Oh, hang on, right up. Wait a minute. Counterclockwise, right up. Whoops, that's wrong. That's 180. That's 909. And that's 0.5. Funny that it's still green. That probably means something. I don't understand why that didn't matter. I essentially positioned a train here and said to go right up. And it went, yeah, anyway, don't think too much about it. Right up clockwise, left is 0.5, that's 0.1, that's 90. Yeah, that's right. Cool. Easy does it. Okay, I can delete these tests now because they're useless. Because all they do is call the same method twice and verify that it does the same thing twice. Which I'm gonna go out on a limb and trust .NET that it will do that. Tell me if you see any problems. Nah, that all looks cool. Alright. Awesome. Let's turn off live unit testing, because we don't have any live tests. And we need to do some more tracks. We need to do the old left, right, down. Ugh, copy and paste. Who's going to type, honestly? It's odd that it didn't work out to show that. Okay, so now, left, right, down. So left, right, down is left. What? There's a speech recognition. I hope you can all hear me, and the speech recognition hasn't been running this whole stream. Do I sound like a robot? Anyway, so left, right, down is a problem because I can't remember what it looks like. So let me run the app and we'll find out. The problem with the T-intersections is there is... Okay, so that's a left, right, down track. So what we want is, if the train is coming up from the bottom, we want it to go to the right. I'm going to write this down. So, we can uncomment that, and uncomment that. So, if from bottom, go right, and if from sides, go down. No, wait. If from bottom, go right down. It's a right down track. If from the left, it's a left down track, and if from the right, it's a right down track. Okay, so 2 states where it's right down and 1 where it's left down. Cool. So the easiest thing to do is say, well, if we're coming from the left, so if we're coming from the left, our angle is going to be near enough to 0 as doesn't matter. So we can say if it's less than 45 and greater than negative 45? Will it ever be a negative 45? Do we need to worry about it being 315? Greater than 315? Maybe we do. Let's go greater than 315 and change this to 4. Turn train movement dot left down and pass in the world. And get rid of this window. Top, angle, distance. And then otherwise we just return right down. That makes sense. Let's see if it works. Now we have the hard part of, so I need to draw the 3-way track. And then I need to work out how do I send a train going that way. And so trains in this game at the moment, when you put them down, they either go right or down. So to come in here, I have to put a train up here. And to come in from up the bottom, I have to put a train here. So, excellent. Oh! Did this not just work? Like, did we not just test all of this before I removed that code? What the? Okay. I guess I did have way too many trains on that track that I was mucking around with. So that worked. These are now stuck in the pattern. Ugh. Oh. Well, something's working. Maybe. I think the 3-way bit is, though. This isn't. But that's starting out right. And this does go down. And that does go down. Okay, so I've definitely got a problem with the individual, like the move right up method. There's something wrong with this. But I don't know what it is. And I kind of wish I had a test that worked now, and I hadn't removed that test. Oh, I'm such an idiot sometimes. Is this one of those ones where this needs to go the other way? This is how I develop things. I just change random numbers until they work. And if they don't work, I swear at them. And, then I'm happy. Yeah, I could compare to unmodified. Oh, okay, so that doesn't work. And that doesn't work. So that was definitely the wrong thing, but the 3-way track is working beautifully. Except, it looks a little jerky. Oh, it is. That left down. Oh. Oh, that's interesting. So it's a little jerky because... Oh, this isn't just the angle you enter it. Ah. this is not just the angle you enter it. This is the whole, for the whole arc of that left down track. So that's left down clockwise. So that's between. So that starts at 0, goes down to 90. Yeah, so this is causing it to jump to the right down path when it's halfway through that track, which is wrong. So I'm going to be lazy and see if this works. Oh, but then hang on. So this is going to go and approach 90, but this is approaching 90 as well. So that's smooth. But then isn't this going to jump? Oh. Maybe it doesn't matter, because I guess by the time they overlap, they're basically straight. Yeah, because this is coming in from one side, this is coming in from the other. Yeah, that makes sense. Alright, so right up is still broken. So right up, let's put this back. Okay, I can't remember what it was doing now. But yes, it's probably a matter of comparing to a modifier and just checking the numbers. Okay, so that's getting halfway and turning around, and this one. Okay, so that works. The difference between them is only 90. Yeah, that's fine though. Like that one's only 90 as well, and so is that one. So, let's think about this. No, let's not think about this. Let's go to GitHub. Isn't the middle numbers? Oh, you mean these two? Quite possibly. Let's go to GitHub and see what track.cs says about this whole thing. Right up. So, negative 45 and 135. There's the problem. A transcription error. And way too many trains on my test track. Let's do this again because it's more fun. Train. Correct. Yes. And yay! Alright, awesome. We're back on track. We've lost almost nothing. This feels so wrong. But fine. Okay, let's do some more tracks. Let's see if we can quickly bang out the next ones. So we have left, up, down. Yep, what else have we got? I forgot what I call all my things. Left, right, down. Left, right, up. Let's go to the left and left. I think I'm already. Right, up, down. Is that it? Is that right? Is there only those many? Yes. Cool. Negative 90 of movement would also work as well. And that's odd. Yeah, I think negative or equal to 90 probably makes more sense. Negative 90 kind of works. Yeah, I mean, either way, it's technically going to jump tracks, but only when they're both vertical, so it doesn't matter. Left, up, down, left, right, up, and left. Sorry, right, up, down. The only problem with these is, I don't remember. I don't remember what. No. Copy, paste. I don't remember which way is the main way for all of these. I don't think it's necessarily easily discernible from the code, but let's have a look. Track renderer. So, oh, okay, yes it is. Right up, down is right. Left, right, down is right, down. Man, wait. So if right up down has the planks. I think this means this has the planks. Oh wait, hang on. No, that's just rotating. Local or the magic numbers within each methods. Patterns will appear. You say that like you what? Probably. Like you mean these three patterns? So okay, draw extra. What does draw extra mean? Draw extra means draw planks, right? Oh no, that means draw an extra track. Oh, that's annoying. Okay, no, rotate to the initial angle. Alright, so the initial angle will draw the planks at. So that means for right up down, we draw the planks on right up, which means that for right down is the odd one out. Yes. So if we're coming, where are we? Right up down. So right up is the odd one out. So if we're coming from the bottom, which means this is 270. Can I get away with equals? Do you think? Nah, no way. I could if it was an int. There's an argument to make these ints. No, but it's not equal. Sorry, no, it's gotta be, what are we doing? We're coming up, so we're 270 and we're flattening out to 0 or to 360. So this is greater than or equal to 270. And this would be move right up, otherwise right down. Okay, let's see if this one works. Right up, down. I remember which one to draw. So right up, down. And then there, and there, and there. So that way? Nope. That way? Also no. Yes! Also that was wrong. Oh dear. Okay, hang on. Left, right, down. Left down is the special one. Left, right, down. Right down is the default. Yeah, so the other one isn't. That makes sense. So right down is the special one in here. Oh, right down is the special one. That's all. I had the math right, I just got the wrong method. Okay. So that way, yes, that way, yes, and that way. Excellent. Wait till tracks have state and you can twiddle those switches. Boy, that'll be fun. Okay. Left, up, down. So, close this file because I keep clicking on it. Left, up, down. Left, up is the odd one out. So, this is move left, up. This is move left, down. And so, left, up means we're coming in from the top, which means our angle is 90. 90 but going to 180. between angles, angle 90, 180. I feel much less confident now about this one. Left, up, down. Left, up, down. Yeah. So, no. Presumably also no. Oh no, that one worked. That was weird. Okay, so that just means my angle calculation. So what's... Oh, that's not... No, it is 90. It's 90 going to 180, isn't it? That's weird. It's 90. Hey! Ah. Between, obviously, left and... Yeah, left and... Okay. Curse you, Scott. Between 89 and 181. I will look back upon these magic numbers 5 years from now. 45? And 180? What? 45? Why 45? Not 45. What are you talking about, Willis? You haven't tested corners into Y tracks. No, that's true. Yes, I did just then. Ha! Take that. That's very true. Oh, God. I don't want to think if that's going to work. Okay. There you go, corner into Y track. Ha! Take that. I don't know where you're getting your 45 business from. That's just kooky. Alright, left, right, up. Left, right, up. Left, right, up is the odd one out. Which means that we don't rotate. Oh, God. I think it's just left up. I'm just going to draw it to double check, but I'm pretty sure it's left up. Left, right. Yeah, left up. Cool. So, left, right, up. So, move right up is the special one, and move left up is the other one, and then right up. So we're coming in at 180? No. Yes. We're coming in at 180, and we're going up to 270. From 79 to 271. Alright, now, in theory, this is everything, and I can draw the most crazy track you've ever seen in your life. Circles and all, and everything will just work. This is every track type. Actually drawing a good one of these that exercises actual code is a whole other matter. I will sit here and I will watch this train. Go, yep. I hope you're all enjoying watching this train go around the track. If you are, I don't know, like, comment, and subscribe. Oh no, I'm going to run a track. Yes. See, this always happens with T-intersections. You end up in these loops where nothing ever happens. This is where you need to switch, because I want that to go that way. And I can, haha, oh damn it. Who said this doesn't have any gameplay yet? It's going to go around there, go around there, go around there. Oh, it's going to end up there. Down there. And it raised that. Yes. No, I followed the train wrong. Go that way. Alright, cool. I think this is great. I think this is done. Oh, I could probably refactor the move vertical and horizontal methods a bit. Yeah, that's cool. And maybe, well, I'll tell you what. These can all take a train position. And they don't have to return anything. Does that mean I can't use a fancy switch statement, though? Let me check this in before I forget. Let me cough for a second. If you're watching this on YouTube many years in the future, know that coughing at the moment is controversial. All track types working. Yes. Alright. Yeah, what are we going to do? We want to get rid of all these float parameters and take it. Train position. Ooh. Oh, except distance. I was going to say this could even be an I train position. And train implements. And actually, we don't want to do that anyway, because we want to apply. We still need to do this detection logic to see whether we should move. So, train position pos. This dot left, this dot top. This dot angle and distance. And then I want to pass in position. And I don't want to do anything else. And then yeah, we just read off these things. Up, top, top. Left, left. Column. That, and left, and top. Nice. Wait, what? Were we never setting... Oh, I guess I just removed that without noticing. Let me just have a look at that. Were we not setting angle? We must have been setting angle. I'm not unless we were. Oh yeah, this angle there. Okay. Cool. So now we can change the move method to take trade position. It's void. Oh, that's so annoying. I really like this fun syntax. Should return all. Switch start direction. Have an idea. Can I convert this to a normal switch? Oh, missing cases. Oh, I'm fine. Okay. Can I convert this? No. Maybe if I fix this up first. How do we want to do this? So this is train position P. And we do this. This is all void. And this gets the same treatment. Oh. I should have refactored these first. Okay. Position dot. What if there's any R's? Nope. Oh, good. Yes. Love it when a plan comes together. Oh, that's not going to work. And this is position. Can't spell. No. Come on. Okay. That should all compile. So this should all compile. Nope. This is void. Wait, aren't they all void now? Yeah, that's weird that one, but this becomes position. This must be riveting to watch. Thank you for sticking with me, if you are. Because I should probably talk more or something, but I don't know. All just copying and pasting. It's kinda thing. And we'll just get rid of all returns. Choo-choo indeed. You know, I do actually have a favour to ask. Which I hate doing, but I'm going to do it anyway. I'm going to do it once. Because I'm not going to do it anymore. But if you have a Twitch Prime subscription, or rather if you have an Amazon Prime subscription, in case you didn't know, you can link it to your Twitch Prime subscription and then subscribe to this channel. And like, I get 3 cents every year, and it's great, but it costs you nothing. So there, I've said it. If you would like to do that, I would much appreciate it. And I will not mention it again for a while. Thank you. Okay. I really am a bit sad that I can't use fancy new Switch expressions. That should not be good. Oh, Rosalind's just going to fight me on the formatting, isn't it? Alright. Scott, you're too kind. Thank you, Scott. And this is a very new invalid operation exception. I don't know what that crap is. I wanted it to go to someone else. Well, look, that Nullops guy, he's alright, you know. We've had good times over the years. Move vertical. What's wrong with this? Oh, it doesn't return. Oh, wait. Would it have allowed a switch expression now that that's void? Oh, I'm too angry to find out. Right up. Right down. Left down. Right down. Maybe I should have better names for these. Why is there no move right up down method? Oh! There is, it's just not there. Yeah, maybe I should have better names for these, like, that more correctly describe the quadrant of the circle, because these are sort of now disconnected from a track, which I quite like. So I really want to see dictionary of action of train position. Yeah, I mean, yeah, I could do that. But so what I want to do in future, and I've mentioned this before, but in case you haven't heard me, because you're watching for the first time, this is all well and good that there's these tracks, and I can turn off the grid so it looks a bit nicer. Not that layout bug. What I would love to do in the distant future is, like, I like the drawing of the tracks like that, so I still need that mode, but I really like there to be sort of a SimCity-esque, you know, find a track piece from the marketplace, from Nougat, I don't know. Find a track piece and have it be like like say, see this little, you know, funny little kink there? Have that be one piece that you plonk down, and so the code for that track piece can then do, well, move through this arc, then move through this arc, then this arc, then this arc, then this arc, and then now you know. Like, because they are really general purpose, those angle ones. Oh my god! Okay. What? So, I'm gonna guess that, yep, yep. I'm gonna guess that I've buggered up the distance stuff in here. Return distance. Return position dot distance. There we are. Man, that was some speedy trains. Okay. Oh, now I've got to draw that track again. I really got to get auto-saving. But I tell you what, now that I've finished movement, now I can go back to fun stuff. And by fun, I mean easy. And I'm really looking forward to it. Because, like, collision detection is actually not that hard, and it's kind of fun. And new track types, and auto-save, and trying to work out this layout bug. That one. Like, happiness. Happiness. I should get rid of happiness. Trains. Relax. Yeah, like, I can actually get some yeah, more fun, but also easier code from now on, which is really good. I'm kind of thinking that I should probably write some tests for these angle code, even if it's just hard coding some, like, I know they work, so I'll just call them and write down what numbers they return and then write them in test cases, just so I can't accidentally break them. Even this move method, like, I just broke it because of distance. I really should have way more tests. I struggle with writing tests on stream. I kind of feel like tests is a really good background job to do on the weekend when, like, the kids are watching TV or something. Like, I don't know. Do you agree? Does anyone leave a comment on YouTube or in the chat if you think that watching someone write tests for existing code is actually interesting? Because, I mean, it's not much fun to do. I don't know that I'd want to watch someone do it, but anyway, this track has no T-intersections, so we shall fix that now. This train will now go this way, because it follows the planks. Interestingly, yeah, that it should draw the one with the planks last, so it's on top. It's kind of weird, since it follows that one. Or I guess I can change the code and make it follow the other one. But yeah, like a switch. I want to switch. But was that a bug? I don't remember what was going on. Oh no! That way. That way. No, that's fine. That way. That way. Oh, found a bug. I'm gonna have to draw out some. You know what? Unit tests. I'm gonna have to. Yeah, that's in there. Corner into a Y. Corner into a cross, maybe? No, it's like this way is working fine. It's that way. That's corner into a curve. Anyway. Yeah, I'll have to work out to draw all of the... Actually, let's just test that quickly. Let's just test that quickly. So that was that. That one worked, but the other way didn't. Yeah. Okay, I've broken left, right, up. Left, right, up. Left, right, up. Left, right, up says 179. And got a layer that draws the train's angle. Yeah, I was actually thinking the same thing. I was thinking last week what I really would have liked was a layer that drew the train's angle and the other angle, for which we still need a better name. It's coming in at 180. That's going up to 270. Move right up. It looks right. Unless I broke move right up somehow. Moves around the corner. I do want to change all of these P's. No, not those P's. Oh. Okay. Vision. Alright, let's just quickly see if we can debug this left, right, up thing. Oh, I need to remove these comments because they're all wrong. But yes, a train's angle on a train might be good. Actually, just having nicer looking trains would be a plus. Wouldn't it? Angle is 180. And angle is now 184. So it's still between. Oh! I took away the returns. Oh dear. Get the community involved. In drawing trains? Absolutely. That would be fantastic. Yeah, I mean, you know, we need a skin library. Oh, marketplace. Sorry, marketplace. Skin marketplace. We need a you know, the ability to upload your own. I don't know. Well, I would like to have like different vehicles. Eventually, I want to do roads. I always wanted to do roads. Roads was like the biggest thing I wanted to add to the JavaScript version was roads, and I didn't because it was way too hard because the code was so fragile. Did I miss one? Did I miss an else? I didn't miss an else. Oh no. Oh, why are there bugs? There weren't bugs 5 minutes ago. I just want to test this code. That works now. Alright, let's watch this. This is up, down, right. It's working. Oh, okay. What the? I'm going to have to check the recording. I'm pretty sure that didn't work 2 seconds ago. That's very frustrating. Yeah, I really want to do roads. Like, I could totally see having different types of trains that can be on the tracks, but also different types of tracks that aren't, you know, left, right, No, what is it? It's right up down. Angle is greater than 270. Side testing. Cars on a half-size grid can have 2 lanes in the same space. Oh yeah, absolutely. No, roads, of course, are 2 lane, 1 lane. Yeah. But like, I want to have stations. I want trains to stop at stations. For no good reason than it's fun. This angle should be 270. It is. It should now increase. It does. Of course that worked. Brr. Is it the corner? Maybe you were right. Maybe it is the corner. No. This was broken. That's correct. This was broken 5 minutes ago. Coming in at 271, you reckon? No, but it went forward, then it jumped. Maybe. Well, what's this? This is 90 through to 0, so I've certainly got some leeway there. I don't know, I'm worried that maybe it's a distance calculation thing. And it's like you just get lucky, you get lucky on the numbers, or you don't. So let's. Okay, that is definitely working, but I don't trust it for a second. So I'm going to test it with funky tracks. And I'm going to put a train there. Nah, that one didn't now. Brr. All right. I'm going to commit this, clean up, and use train position everywhere. Yeah, write a comment on the YouTube video whether you think writing tests for existing code is worth watching. Because I don't, but you know, I'm only me. I'm only but one opinion. And we should say, oh, provide a method name to loadable. Really? I'm just gonna I can actually get rid of all of these now. And I don't even need this, I don't think. I'll put it back if we want to. I think. IntelliCode refactorings. Thank you, IntelliCode. You possibly would have been helpful. Suggested edits move around corner. What were they going to suggest? That. No, that makes no sense. Okay. So IntelliCode has seen that I took off the static method name. Oh no, it didn't. It didn't say that at all. Huh. I could actually do that, we've done it. Anyway. Alright, now I've got some more changes to commit. God, why do I always do that? Okay, cool. Thank you all for watching. Thank you for chatting and gifting subs and whatever else. And I will see you again next time we have some choo-choo magic and we try and work out what the hell those numbers mean. Cool. Have a good evening.